Where is that going to go from here? It's hard to imagine where it would head after this point, right?
Yeah. I think that's probably what people are trying to figure out. What's next? The benefit to stuff like this is you're starting to see it utilized once again, in conjunction and combination with other equipment. So potentially finding ways to amalgamate or utilize data from one that can be fed into the other. So you're starting to see it a lot in like AI and machine learning, having data like ours come through in real time to be fed into machine learning processes or AI.
Welcome to another Fascinated by Shipwrecks podcast. I'm very excited to have Brenden St John from Voyis Imaging Inc. here today with us. He's going to be talking a little bit about how Voyis's technology was applied and used on the Endurance expedition. Endurance was found over 100 years after it sank in the pack ice in Antarctica, and it was manned by Ernest Shackleton and his crew of, I think it was 27 men, or altogether it was 27, and they had to go through grueling events to get themselves back home, to have been able to go out and find that ship and then be able to bring it back in sort of this wonderful image has just been incredible. And of course, it was a very difficult expedition for Shackleton, but even in modern day times, with our modern vessels and modern technology, it's still a challenge to work in that area. I'm really excited to have Brenden here to talk about some of those things, and welcome, Brenden.
Thank you for having me. Yeah, I mean, even to touch on some of that, I think I can talk a little bit about the expedition and how grueling it was because, as you mentioned, it wasn't the easiest even in modern times. In fact, this was the second one in which they actually found it. But there was a lot of people on board the vessel and a part of the team who, yeah, went through that, and it was quite the feat to finally find it and get to image and model it. So yeah, excited to be part of it for sure.
So can you tell us a little bit about what Voyis does? Because there's so much today that's talked about around digital twin, photogrammetry, and all of these sort of, enhanced images that the general public sees, but we don't know what goes on behind the scenes with how that technology works and how it's all brought together to create this 3D sort of image.
So essentially, Voyis, we do underwater optics systems, so underwater lasers and cameras, and utilizing this technology to build out 3D models of underwater environments, targets, shipwrecks, really anything you want to get a sense of underwater, of how to analyze it, and get like a really good depiction of what you're looking at. As you mentioned, digital twins these days are all the rage, and for good reason, right? They play a big purpose across various industries, whether it's the offshore industry, ocean science that I deal with, the civil, even in defense now. So it's a way to get a sense of what you're looking at underwater without sending somebody down, using autonomous systems, using robotics to get to places that potentially you couldn't get to otherwise, to analyze the environments and analyze assets. So that's what we try to help out with. Like I said, there's a lot to go into it. A lot of the time we're working in conjunction with other systems, other technologies to bring everything together to get to the state where you see our models and our images and stuff like that.
So how does that work? Like you have a particular kind of asset that you use, but it might piggyback on another system in order to bring those images back.
I guess the endurance expedition is a perfect example of that. So the amount of different technologies that went into play to find the wreck before we could even utilize our equipment to actually model it and image it are essential and a lot of the offshore or a lot of the subsea space. So a lot of the time you'll work with one, obviously, the main vessel to deploy some sort of potentially robotic system, so an ROV and AUV that can, in this case, try to find what you're looking for underwater. You have technologies such as sonar-based systems or multi-beam systems that have the capabilities of covering wide areas, so they can have swaths on either side, like a side scan sonar that's capable of covering potentially 150 meters on either side. One of the disadvantages potentially of those systems is the resolution you're looking at isn't always the greatest for helping identifying what you're looking for. You can find maybe an anomaly on the seabed that you know is different from the surrounding area, but maybe not high enough resolution that you can identify it's the shipwreck or it's a rock or it's anything like that, right? So we have to utilize those technologies before we can a lot of the time even get to ours because though ours is very high resolution, it's got somewhat limited range. So to cover the wide areas and the vastness of the ocean floor, it would take far more time to use a technology like ours. So we work in conjunction with a lot of other systems out there. And anybody who's seen, obviously, the documentary on Disney will get a good sense of that. A lot of it does focus on trying to actually find where the wreck is first before anything. And the area that they have to cover is immense. So we were lucky enough that obviously we were able to find it and then come back around and utilize the high resolution sensors like we offer to then map and model the asset, the wreck. There's a lot of technologies that come into play on projects like this in the offshore space, ocean science, all working together and all providing a different part to get to the end goal.
Right. I believe that Endurance was found just over 3,000 meters below.
It's pretty close to 4,000 if I'm not mistaken, so just
Yeah.
under 4,000. So yeah, quite deep, obviously.
Wow. So it's amazing to think that it has been found and that we've been able to, just the regular everyday person can just go to their computer, watch the documentary, but they can see these images online and sort of get that sense of being there and seeing the wreckage, right? How does your technology change that resolution? Like it became sort of more like how you would have seen the ship if it had been sitting on shore. What's happening there? I've never heard of that before. I don't know how advanced this technology is, but it's interesting to see because we often see shipwrecks sort of in this murky environment.
I think it was a couple things that come into play. I'd like to say that it was all just our technology that helped get the good results, and it definitely plays in part of it. We were lucky with this shipwreck in particular, as opposed to some of the others that you'll see in maybe not the greatest water conditions, so that can impede the clarity and quality of the data you're getting. Whereas obviously in Antarctica, pretty well protected from having turbidity or particulate floating around in the water, and especially that deep. So the clarity of the water helped immensely. But in terms of the actual technology, yeah, we do what we call image enhancements. So real-time image enhancements where we're doing things to our data as it's being collected that a lot of other systems aren't doing. So we're leveling light across the entire image. So the images you're seeing, one, have enough light because underwater with imaging, you can't really ever have enough light. And then utilizing that so you're not getting any dark shadowing on the corners or anything like that. We're undistorting the images so that you're getting that clarity and removing any artifacts or effects of the water. And then we're doing what we call true color correction. And I think this is what you're alluding to. Trying to correct based on some machine learning algorithms, correct for the hue of the water. So obviously underwater, you've got that natural green-blue hue. We're trying to remove that so that you can see the asset underwater as if it was on land. So I don't know of a lot of other systems out there doing it. We've worked with a couple of universities in the past to help develop these solutions as well. And just trying to provide that sense of what would it look like if it was still on shore. Obviously, colorization underwater can tell you a lot of different things about the conditions that you're looking at in terms of the asset. Once again, whether it's a shipwreck or an offshore pipe or anything like that. So we want to be able to provide that clarity as best as possible to help. In this case, I got a chance to speak with Nico and do a presentation with him at Ocean Business. And he was telling us some of the things they were able to find in the data because of this process, because of the clarity of the images and the colorization they hadn't seen ever before. And even now, when they go back through some of the data, they're picking out things that previously they hadn't seen. So that's always the goal with us. We want to try to just provide the best data possible. So the analysis that can be done on it is something that the user can find new things in it that they hadn't imagined, or just carry out highly accurate analysis for obviously other purposes.
And maybe you can explain who Nico is because you mentioned him quickly.
So he was the expedition manager with Deep Ocean Search. So if you haven't seen the Endurance documentary on Disney, you'll see a lot of him in it. He was one of, but not the only essential person in trying to find Endurance and helping with this expedition. And at the end, I'll probably shout out a couple other people because this was really a team effort. As I mentioned before, you couldn't have done it with just one technology, but also there was an amount of different companies involved, and the teams that everybody provided were essential and trying to find the wreck and then getting the data. It was really neat to see that it was such a team effort, bringing people from all different companies, all different countries, together with kind of a one end goal. And it obviously paid off. But yeah, so there was a lot of people involved in this project, Nico just being one of them, but he's one of the stars in the documentary amongst others.
There were team members on board ship on site, and then Voyis, your team were working in your offices, right? So just trying to allude to the fact that, there was both on-site team and on-shore teams that were working on this.
I'm glad you brought this up. This is one of kind of the neat things about obviously technology in this day and age. This was all taking place during COVID. Once again, if you watch the documentary, everybody's got masks on and everything. And so unfortunately, we weren't able to provide somebody to be on vessel. So we were supporting from our offices back in Canada. And that's one of the neat things. We had people on board the vessel that we could relay information to and actually be online while the technology was being used to ensure that we're able to collect the data we want. So making the adjustments to the hardware, the settings, and support that from almost as far as away you can get up in Canada from Antarctica, and be part of the team even if we couldn't physically be on board the vessel. So it was quite amazing to be able to do that.
So I can imagine there would be lots of hours during that, sort of 24/7 operation. And then even afterwards, you're still collecting data, still utilizing the technology to look closer, find other aspects like you were talking about, and then of course disseminating it to the team so they can be doing continue their research. So what is that sort of grueling effect of the human body, on having to do all of that research and be, available and sort of, on target when you need to be?
Yeah, I mean, I can say from the Voyis perspective, we were kind of lucky in the sense that we weren't necessarily online the whole time. Our technology wasn't really used until the near the end when they actually found the wreck. So we didn't have to maybe go through as much of a grueling process as obviously everybody on board and everything. So obviously the processing time afterwards, disseminating the data, that took a little more time. Once again, Nico and his team helped with that too, the processing of all the data. We had a lot of people involved in that, a team from a university here, McGill University. It was really a team effort, which then helps obviously alleviate some of that stress, some of that weight that you're feeling. And there was time to it too. People understand within the industry that it's not an overnight process. We collect a ton of data. There's a lot to go through, and it's going to take time. It took time to find the wreck, and then kind of some of the post stuff is going to take time as well. Everybody's very kind of understanding and gets that if we want to showcase the data at its fullest, the process needs to be worked through, and it's going to take a bit. But yeah, everybody who participated in it, who helped out, was awesome and helped obviously alleviate some of that. So it wasn't just on us. There was teams all working together once again. One of the biggest aspects of this project was just the team effort that went into it from all different companies. Everybody played a role, everybody worked together, and it's why it was so successful.
It's hard to imagine as a person just sort of sitting back and watching the documentary. You get some sense of the hard work that's going on, but you can't imagine what's happening like after hours or off screen, off camera, all the rest of it that goes into something as huge as this. I mean, yes, there's been a lot of other shipwreck investigations that have gone on, but I guess this was a big one because it's one of the latest and most famous. So it was a big deal for a lot of people.
The endurance wreck being the second time they were going to try to find it, probably was a little more pressure. I can't speak to everybody on board the vessel because they were going through a lot more pressure and a lot higher stakes game than we were. We were back here and got to sleep in our own beds and everything, and sometimes get calls in the middle of the night. One of my colleagues, I can distinctly remember him doing that. So we didn't have as much on us, but yeah, that's exactly it. Everybody on board that vessel, with such a tight window and a short time frame to try to find it, they're huge in this project because without their efforts and going through that, we wouldn't have found it, right? The wreck wouldn't have been found. So it's really Yeah, all about kind of what they were doing to make sure that it was a success. And like you said, it doesn't really stop. You're kind of going all the time, right?
Mhm.
They really need to be applauded for that because it was everybody on board that vessel that made it happen so that we could get our technology out there too.
And I would imagine afterwards, like you said, it takes a while to get through all of that. So, what is the image behind you? What's that?
I came into the office today. Normally I work from home. I came into the office today because one of the big ones we have in one of our meeting rooms is obviously the kind of the big famous one that probably everybody's seen. It is the Endurance wreck. So it's on one of our walls back here. That would be kind of the full photogrammetric model of the Endurance. You can kind of see some of the details, the high resolution. You can see the boot and everything on board. So I thought that was fitting to have it in the background for me.
Yes, it's wonderful. It's just it's almost feels like it's a painting somebody did or something, like they just
Yeah.
sat there and sketched and then drew it for hours on end. It's just amazing how technology works these days. Maybe you can speak to some of the other Voyis projects that have been in the maritime archaeology space.
Yeah, so we've done a couple high profile ones. We were also a part of the data would come out about 2 years ago now, and once again on Disney, they just released a documentary about the actual model and analysis of the model for Titanic. So we utilized our imaging systems and laser system on the Titanic scan with a company called Magellan. So those are obviously probably the two biggest ones maybe that we've been a part of within the marine archaeology space in general. And then we've been a part of a couple other big ones. Most recently, we were doing some work with NOAA, helping develop a new Great Lakes sanctuary. I think they modeled, and we haven't seen them just yet, about 37 wrecks, some of which they didn't know before that were there. So that was pretty neat. Like NOAA's some German U-boats off the coast of the east coast of the States. So a lot of big ones, and we're hoping to be part of many more now, especially with some of this coming out. Hopefully, it gets our name out there. But yeah, we've been a part of some pretty big ones, I think.
I guess it's like anything, depending on the project profile, you decide what assets need to be utilized for that particular project. So it's all project specific.
We initially started up as a company that focused on underwater laser scanning, and one of the U-boats I mentioned, we did with our underwater laser scanner, and it's great. It looks amazing. We slowly transitioned into subsea imaging as well, so another optical-based system. And I think when it comes to marine archaeology, laser scanner has its benefits in certain industries, certain applications. When it comes to marine archaeology, I think we're starting to find that imaging tends to be the way to go. Build out photogrammetric models with imaging. The details you're able to get, the color when it plays such a role sometimes in the condition of the asset or identifying objects that you potentially couldn't see with laser, where color is of importance. I think it is quite beneficial to utilize the photogrammetry aspect of it. But you're right, it's project specific. It really does depend on what the end goal is for the project. And we help work with the client, work with the team to determine which system or combination of systems is going to be most beneficial to get the data that we're looking to get out of it.
And are all of those systems like deployable underwater, or are there any assets that work onshore?
Generally, we focus on underwater. We have maybe one or two that we do onshore, but that's not our bread and butter. In terms of the onshore space, there's a lot of other technologies out there that potentially are better than ours onshore. Our focus is always on being the best that we can be underwater, and so we tend to just stick to underwater.
So when it comes to this kind of underwater technology, there's so much of it now, in different spaces and in different, assets across different types of projects, like you were saying, subsea, which is a whole other industry. But, it's hard to imagine when the general person is kind of going, well, photogrammetry, wow, these 3D images, like where is that going to go from here? It's hard to imagine where it would head after this point, right?
Yeah, yeah. I think that's probably what people are trying to figure out. What's next? The benefit to stuff like this is you're starting to see it utilized once again, in conjunction and combination with other equipment. So potentially finding ways to amalgamate or utilize data from one that can be fed into the other. So you're starting to see it a lot in like AI and machine learning, having data like ours come through in real time to be fed into machine learning processes or AI onboard vehicles, for example, to aid in decision making. So navigating with the vehicle based on data that's being collected. So things like that, I think are kind of where we're seeing something go in the immediate future. Long term, that's a great question. I mean, better ranges, better quality data, yeah, combining solutions potentially. It can be, I mean, the nice thing about this industry that I've found, and one of my favorite parts is the evolution, the continuous improvements, and where it's going next is kind of unknown, but seems to be absolutely amazing.
So, do you have anything else to add or highlight from either the Endurance expedition or from what Voyis is working on now?
Obviously, the endurance expedition, one, I think I touched on it a couple times, but it really should be stated how much of a team project it was. You have companies like Ocean Infinity, who were obviously providing the subsea vehicle, so the Sabertooth, carrying out the surveys, and without them, obviously, we wouldn't be able to actually find the wreck. You've got companies like Deep Ocean Search, Nico and his team, who were immense and planning that out. John Shears, Madsen Bellin from Falkland Maritime Heritage Trust. So University of McGill that we worked with here as well. There were so many people involved in the project. I think they need to be shouted out too, just because, like I said, we were one small aspect of it, and our stuff wouldn't have even been used if it hadn't been for everybody else. So we're lucky enough to just be part of the team. In terms of what we're working on now, I mean, we've got a lot going on. I focus on ocean sciences, but we are in defense space, offshore energy, civil infrastructure. So utilizing our technologies across the blue economy or the blue space to really just help in any way we can to develop those models and showcase the tech. So yeah, I think that would be kind of about it. I mean, I'm always excited to talk about it. As I mentioned, I was lucky enough to do a presentation at Ocean Business with St John and Nico and talk further about it there too. The expedition Shackleton and his team, as you mentioned at the beginning, the grueling efforts they went through to stay alive. It's absolutely astounding that all of them survived and what they went through for so long. It's scary to think that I don't know if anybody could do that in this day and age, but they were absolutely amazing. And then conversely, the efforts that went into trying to find the wreck this time around, and how much went into that, the team effort. I know it's a big deal. I know it's a big project when it's hit the mainstream and my mom's heard about it. If she's heard about it and has asked me about it, then I think I think it crossed over into the mainstream and we know that's kind of a big thing because it does feel like a very niche industry sometimes when you tell people what you do. So it's always cool to be a part of the projects like this where globally everybody's heard about it and it touches everyone in some way.
That is fascinating in its own realm.
Yeah.
I'm sure it makes going to work every day quite exciting.
I mean, I love what I do. Maybe not a lot of people can say that, but when you get to work on projects like this every day, and it's always something new, which is cool too. It's neat about the industry in general. When you actually get to work in the space, you truly realize that there's so much to discover under there still. Wrecks like this, wrecks we haven't discovered before, new species of fish, coral, just everything that's there that we know so little about. So getting to work with that every day and working with technology that can hopefully provide a little more insight and shed some light on these environments and stuff like that is yeah, it's always fun. So I can't complain.
Well, thank you so much for your time today, Brenden.
Of
This has been
course.
super fascinating to look at the technology side of what goes on with shipwreck investigations. So I appreciate your time and thank you so much again for joining us. And I'm sure we'll probably talk to you again.
Yeah, that would be great. Thanks for having me. I appreciate it.
Okay, bye for now.
Bye.
Beneath the ocean silence sways, lost in time the wreckage lies, broken masts and shattered pride. In the deep the answers hide, echoes of the past call out, whispers from beneath the waves. What secrets do the shadows keep? Do we dare disturb their sleep?